Page 305, question 7. You're working on the 5th floor of a building at a height of 18 meters above the sidewalk. So we have our building on the 5th floor, and this is 18.0 meters from the ground level. A construction crane lifts a mass of 350 kilograms from street level to the 12th floor of the building, 22 meters above you. So our 12th floor here will be 22 meters above where you're standing on the 5th floor. So our mass is 350 kilograms going up to the top. What is the gravitational potential energy of the mass at street level? So we are taking our height equals 0 at where you're located. So part A, when we figure out our gravitational potential energy, mgh, we have 350 kilograms for the mass. We have G is 9.81 meters per second squared, and our height is negative 18 meters because you are 18 meters below where you are standing. So times negative 18.0 meters. Plug that into our calculators. And we get a value of 350 times 9.81 times negative 18 gives me negative 61803 joules of energy. So that'll be negative 6.18 times 10 to the power of 4 joules of energy. Now, part B asks when it's at the 12th floor. So when this is at the 12th floor, that means that it's going to be 22 meters above our 0 point. So for part B, EG equals mgh. So again, 350 kilograms times 9.81 meters per second squared times our height, 22.0 meters. So 350 times 9.81 times 22 gives us a value of 75537 joules, or 7.55 times 10 to the power 1, 2, 3, 4 joules. Just double check my answer here. Good. And part C, what is the change in gravitational potential energy as it is raised? So for part C, two ways to work this out. We can figure out the gravitational potential energy using mgh. So again, 350 kilograms. G is 9.81 meters per second squared. Our height is 18 meters plus an additional 22 meters. So that's going to be 40 meters. So 350 times 9.81 times 40 gives us 1.37 times 10 to the power of 1, 2, 3, 4, 5. Or we can take our final energy, subtract our initial energy. So we can look at the change in gravitational potential energy. So that will be the final value, 7.55, times 10 to the power of 4 minus our initial value, which is negative 6.18 times 10 to the power of 4. And if we go 7.55 times 10 to the power of 4 minus negative 6.18 times 10 to the power of 4, that will also give us 1.37 times 10 to the power of 1, 2, 3, 4, 5 joules. So either way, you can think about gravitational potential energy to calculate it and still get the correct answer.